Welcome to Class 10 Insight. We are here with one of the important numericals with respect to convex lens. Here is the question. Calculate the distance at which an object should be placed in front of a convex lens of focal length 100 cm to obtain an erect image of double its size. First, let us write down the given parameters. They have given the focal length of the convex lens is 100 cm. As we know, the focal length of convex lens is positive. We will be taking the value as plus 100 cm. We are supposed to find out the distance at which an object should be placed. That is, suppose this is the object we are talking about. At what distance it has to be placed from the center of the lens, we are supposed to find out that. It is represented with small letter u. That is the distance from which an object is placed. And what is the nature of the image they have mentioned in the question? They are telling the image formed is an erect image, and also it is double the size of the object. If AB is the object, A dash B dash is the erect object formed double the size of the object. These are the clues they have given. And we know the formula which relates focal length, image distance and object distance is the lens formula. Suppose we have to find out, and we know by the rules, to find out one unknown value, we should be knowing two values. If two values are known, only then we can find out the third value. We know the focal length, but do we know the value of V? No. So go back to the question and check what is the clue, what else is the clue given. Here is the clue they have given, that the image formed is double its size. Means it is double the size of the object size, which means that the magnification is 2. Magnification is 2. Magnification is equal to V by U. This is known to us from the formula. Let us consider this. We will get V is equal to 2U. Let us substitute V is equal to 2U in the lens formula. That is 1 by F is equal to 1 by 2U minus 1 by U. Now the denominators are same. We can start with the simplification. What is the value of F we need to substitute? It is 100 is equal to 1 by 2U minus 1 by U. On simplifying the RHS, the denominator, by taking LCM, we will be getting it as 2U square. Changing the numerators, U minus 2U, that is equal to minus U by 2U square. 1U in the numerator, 1U in the denominator gets cancelled. 2U is equal to minus 100. U is equal to minus 100 by 2. U is equal to minus 50. Since the unit in the question is centimeter, the answer we take also is centimeter. That is the answer. So 50 centimeter from the center of the lens. Since it is negative, it has to be placed to the left side of the lens. So what is the answer? Therefore, the object has to be placed 50 centimeter in front of the lens, that is to the left side of the lens.